And finally, in stage 2, we identified and delayer the programs of the pavilion in terms of the roof, the structure, steps, platform, seating, ramp, and the floor circulation. And this section sort of explains the relationship between these programs. And then we sort of compared the relationship between the individual footprint that we started with and the programs, and we saw how these overlaps really happened. And to understand that better, we cut like 5 sections throughout the pavilion. And here you can see that, the color actually shows the different footprint that is occupying the pavilion, whereas the pattern shows the program. So, using this analysis, we sort of created a system for the pavilion in a very mathematical manner, where we started with comparing the dimensions, identifying the larger footprints, extracting the inner footprints, identifying the angle of rotation, offset, and the scale. And finally, also identifying the displacement in terms of a multiple of A, which was 25 mm. And we finally put this all together in this table, to compare the initial breadth or the radius of the shape and what sort of operation happened before the displacement, and then what was the displacement that took place, and finally what was the footprint that was used in the plan the way it is in the pavilion as of now. And this is simplified in this 3D representation of the formation of the pavilion. And using this research, we sort of started, trying out iterations where the main, it goes back to the main intent of the studio, where it was a mass production of the non-identical part. So although they are all visually non-identical, there is a trace that is left detectable in all the end products. So in the first iteration, the scale was kept constant while all the other operation parameters were changed. In the second iteration, the scale, orientation, and displacement was changed. In the third iteration, the initial programs were interchanged. And finally, in the fourth iteration, the area distribution of programs was changed. So after the iterations, we sort of took a step back and started looking at the structure, and we realized that the structure actually happens as a result of intersection. So we were able to identify 6 columns based on the shapes that we identified initially. And after multiple trials, we found out that the sets of footprints that intersect with each other create this column, and in some cases they also intersect with the circulation axis. And you can see that in these diagrams. And it must also be noted that multiple intersections took place, but which intersection was chosen was purely the architect's choice. And while it gave away the location, the shape was again completely based on the architect's discretion. So moving on, we sort of thought that to make better iterations, we need to come up with a controlling parameter and analyze its relationship with the roof and the platform. So we made these new iterations where you can see that it's summed up in this table, where the seating sort of had a direct relationship with the platform, an inverse relationship where as the seating area increased, the platform area decreased. So it was directly impacted by seating, which became the controlling parameter. And this then affected the accessibility in terms of height, and this in turn affected the sunlight penetration as well. So taking forward seating as a controlling parameter, we chose to work with these two methods of operation, which is scaling and displacement of footprints to control the area, and varying the positioning of footprints to control intersection points. And finally, we came up with a method for growing the pavilion on site. And at this point, we were not introduced to the site. So we were imagining the site and sort of working on a series of steps that might work when the site will be introduced to us. So in this step, we sort of, thought that we can come up with an axis which will come from site eventually. And the growth will then be based on factors like orientation, displacement, and scaling, which will depend on site conditions, largely obstacles like trees and boulders, or site conditions like the wind direction or north light. And to further detail out, the way the axis will work, we thought that the center of the first circle could be placed on an existing node that will come from site. And the way it grows is that the radius of the next circle will be equal to the distance between the two nodes. And then each center of the new circle will be placed on the node. So looking into this further, we thought that the overlap spaces can actually act as public or semi-public spaces eventually on site. And then we started thinking about what kind of access can actually happen on site. But these were some possible actions out of which we chose to go ahead with the flow of water. So this is when the site was actually introduced to us in the last stage. And we identified the flow of water according to the ridge conditions, and we chose the central axis in responding to the proximity that it lies in the center of the site. So we chose to work with the central axis, and then we identified these node points that happened on this axis, as mentioned in the method of growing earlier. And based on these node points, the distance between the two node points became the diameter of the circle. Also keeping in mind that the placement of the internal footprints will not overlap with the trees, and the orientation of the
Hello.
yellow footprint
Hi, Pranav.
will.
Sorry, but we are running short of
Yeah,
time,
yeah,
so
yeah.
you would have
It's
to
ending.
move faster.
Yeah,
Yeah, yeah.
almost done. So the orientation of the yellow footprint, which later converted into the living unit, was faced parallel to the river. And then this is how it grew on site. And eventually, the overlap spaces acted as the public spaces, while the other spaces became the living units. And finally, the flow of water culminated into a large water body on site, which was at the lowermost contour level. And then, using all of this research, we translated it onto site and started making these plans where the yellow became the living units, the blue circles became semi-public spaces, and the violet rectangular space and these pavilions that happened across site. And then the existing path was introduced, and finally we started detailing out the plans where some spaces became the private residential units according to the nature of the space, while the others became like a co-living sort of a scenario. And this here you can see the public spaces in the rectangular violet boxes. And this is the plan at 93 meters, which is the lowermost level, which has a relationship with the water body. And here in the sections you can see the difference between the way the residential single unit works with the water body and the way the co-living multiple units work. And these are some examples of the public spaces which largely had these programs. And finally, how the interface was created with the water bodies in the section.